Have you ever felt like you're copying and pasting the same code over and over again? Maybe you're writing the same output statements, doing the same calculations, or repeating similar logic. Well, what if I told you there's a smarter way? A way to write code once and use it whenever and wherever you want, without duplicating anything. That's exactly what functions do. They allow you to break your program into smaller, reusable pieces, each with a clear job. And the best part? Your code becomes easier to write, easier to read, and easier to fix. In this video you'll discover what functions really are, how they work in C++, how to pass data into them, get results back, and avoid the most common mistakes. Whether you're building a calculator, a login system, or even a game, you need functions. Let's unlock this fundamental C++ superpower, together. So, what exactly is a function in C++? Think of a function as a mini-program inside your program. It's a named block of code that does one specific task, like printing a message, calculating a sum, or checking a password. Instead of writing that task again and again, you write it once as a function, and then you just call it whenever you need it. It's kind of like using a coffee machine. You press a button, and the machine takes care of everything. You don't have to grind the beans, boil water, or pour the coffee manually every single time. The machine handles it for you. In programming, that button is the function name, and behind it is all the code you wrote once, hidden neatly out of the way. Functions help your code stay organized, modular, and reusable, which is a fancy way of saying cleaner, easier to test, and way less messy. Now let's learn how to actually write a function in C++. A function has four main parts. First, a return type. This tells us what the function gives back. Then, the function name, which you choose based on what the function does. Next, parameters inside parentheses, which are optional, and let you send values into the function. Finally, the function body, inside curly braces, where you write the actual task. Let's look at a simple example. We'll write a function that prints a message, hello, Codeverse. Because this function doesn't return any value, we use the keyword void. That means, no return. The name of the function will be say hello. And inside the curly braces, we'll just put one line, cout, hello, Codeverse. And now, to use this function, we call it by writing say hello, wherever we want the message to appear. That's it. By putting the logic inside a function, we've made our code easier to manage, and we've avoided repeating ourselves. Alright, now let's make our function smarter. Instead of always doing the exact same thing, what if we could send data into a function, so it reacts based on what we give it? That's where parameters come in. Parameters are like placeholders for values. When we define a function, we write parameters inside the parentheses. When we call the function, we send in actual values called arguments. Let's say we want to greet someone by name. We can define a function like this, void greetUser, string name. Cout hello, name Kendall. Here, name is a parameter of type string. This function will now say hello to whoever we pass in. So if we write greetUser, Alex, the output will be, hello, Alex. If we write greetUser, Lena, the result changes to, hello, Lena. The function logic stays the same, but the output adapts, based on the input. And just like that, our function became flexible, reusable, and dynamic. Until now, our functions have just done something, like printing a message, but they didn't give anything back. But in many cases, we want a function to actually calculate something and return a result we can use. That's when we switch from void to a return type, like int, float, or string, depending on what we expect the function to produce. Let's take a simple example, a function that adds two numbers and returns the result. Here's how it looks, int add, int a, int b. Return a plus b. The return type is int, because we're returning a number. The function takes two integers, a and b, and it uses the return keyword to send the result back. Now, in main, we can store the result like this: int result equals add 3, 4, cout is sum, result end L. This is super useful, because instead of just doing something, the function becomes a tool that we can plug into other parts of our program. Want to subtract? Multiply? Calculate area? You just return the value, and the rest of your code decides what to do with it. That's the power of return values. They make your functions interactive and useful in bigger calculations. Alright, before we move forward, let's talk about a few common mistakes beginners make when writing functions in C++. Mistake 1, forgetting the return type. You must specify what type of value your function returns. If your function returns a number but you forget to write int or float before the function name, C++ will be confused. Mistake 2, writing a return type, but not actually returning anything. For example, int greet. Cout hello. This code is invalid because the return type is int, but there's no return statement. C++ expects a number to come out, but nothing does. Mistake 3, using parameters incorrectly, like calling a function without passing the required arguments, or mixing data types. Mistake 4, defining a function after using it, without telling the compiler about it. In C++, you either need to define your function before main, or you need to declare it with a function prototype like this: int add, int, function declaration. C++ reads code from top to bottom, so if it reaches a function call before it knows what the function is, it throws an error. The good news? Once you know what to avoid, these mistakes are easy to fix. Let's bring everything we've learned together with a real example. We're going to build a mini calculator, one that can add and subtract numbers using functions. We'll write two functions, one called add, that returns the sum of two numbers. Another called subtract, that returns the difference. Each function will take two parameters, int a and int b, and return an integer result. Then, inside main, we'll call these functions with sample numbers, store the results in variables, and display the output. This is the kind of structure you'll use in real projects, not just printing text, but building tools that actually do things, and separating logic into clean blocks of code. Let's code it. We start with two functions, add and subtract, both returning integers. Each takes two integer parameters and returns a calculation. Inside main, we define two numbers, 10 and 5, and call both functions. We store their results in variables, and then display the results using cout. Time to test your understanding with a quick challenge. Take a look at this function and try to figure out, what will it return when we call mystery, 3, 4, here's the function. Int mystery, int a, int b. Return. A multiply by b minus 2. Let's break it down. We're multiplying a multiply by b, which is 3 multiplied by 4 is equal to 12. Then subtracting 2. So the final result is 10. Let's see if you got it right. Awesome work, you've just unlocked one of the most powerful tools in C++, functions. Now you can write cleaner, smarter, and more organized code, by breaking your programs into simple, reusable parts. From basic tasks like printing messages, to advanced logic like calculations, input, output, and more, functions are everywhere in real-world C++ applications. But we're not done yet. In the next video, we're going even deeper. We'll explore function overloading, where you can write multiple functions with the same name but different inputs. And we'll uncover the secrets of variable scope, what happens inside versus outside a function, and why it matters. So stay tuned, hit that subscribe button if you haven't already, and let's keep building your C++ mastery, step by step, right here on Codeverse.